Hey, grade sevens. We're just going to do a quick review on solving equations. Um, we'll be doing a final quiz test coming up here right away. So just want to go over what we've been talking about. So an equation has two expressions equal to each other, two expressions that are the same thing. So I have four equations here. Let me just get a different color here. So A here has two expressions. One expression is 8. Whoa. One expression is 8. The other expression is x plus 3. These are equal to each other. So 8 and x plus 3 are the same amount. So one way that we've been able to solve, and when we say we solve these equations, we're trying to figure out what x is, or it could be any other variable. So this is a variable. We're trying to figure out what is that variable equal to. So let's do A here using our teeter-totter analogy. So a teeter-totter is balanced, it's flat when both sides have the same thing on it, the same weight. And in this case, that is 8. So 8 counters, 1, 2, 3, 4, 5, 6, 7, 8. So 8 on one side, and on the other side, there's one x, so one unknown. We can draw a box with an x on it. So there's some certain number of counters in that, and then there's 3 counters. 1, 2, 3. So we want to know how much x is equal to. Well, I could take away, so to find what it's equal to, I want to have just x on one side and just the number of counters it's equal to on the other. So to get x by itself on this one side, I would have to take away, those 3. Now if I just did that to that one side, suddenly my teeter-totter wouldn't be balanced, and the x side with the x on it would be lighter. So to keep it balanced, I would also take away, at the same time, 3 from the left side. This causes both sides of my equation to remain balanced, and now I'm left with x on one side and 5 on the other side. Therefore, x is equal to 5. So what we did here, if we were just going to show just the math, not the diagram, I took away 3 on this side to get rid of this plus 3, and I took away 3 on this side. 8 minus 3 is 5, so x is equal to 5. Okay. We can put 5 back in for x, and we see 5 plus 3 equals 8, so our answer is correct. Okay, so that's A. Let's do B here quick. So B has 4 on one side, 1, 2, 3, 4, and x divided by 3 on the other. X divided by 3, so this could also be written as x divided by 3. It also is the same thing as 1/3 of x. Okay, 1/3 of x. So if we have a strip that is split into thirds, and if this represents 1x, there's 1/3 of it is filled in. Well, if this is x, we want to know how much 1 whole x is equal to. Well, if I times it by 3 and I got another third here, another third would be another 4. So since I added a third on that side, I have to add what that is equal to on this side. And I would add another third. So essentially I'm timesing the right here, I'm timesing it by 3, and on the left I'm timesing it by 3. And now my 1 whole x I see is equal to 12 counters. Okay? So x is equal, this is x here, this is 12. So x is equal to 12. When we're just showing the math, if this is x divided by 3, I usually like to have it shown like this. X divided by 3, I multiply by 3. I also multiply the 4 by 3. Then I'm left with 12. The multiplying cancels out the division. 3 divided by 3 is 1, so I'm left with 1x. So 12 is equal to x. I can put 12 back in for x there. 12 divided by 3 is equal to 4. So that's how I know that my answer is correct. If you somehow got, 15, x is equal to 15, and you put 15 in place of x, well, 15 divided by 3 is equal to 5, not 4, so you know that your answer is wrong. Okay, so you always substitute it back in to check that your answer is right. 2x is equal to 10. So on one side, I have x, I have x. The other side, I have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I want to get just one x on the left side. So to do that, I can take away an x. That doesn't mean I only have to take away one counter. Since I'm taking away one x, I'm actually taking away half of the weight on the left. And so I would also have to take away half of the weight on the right to keep it balanced. Okay, I took half away on each side. Or taking half away is the same as dividing it by 2. So now I'm left with x is equal to 5. So on the left, I divided by 2. So 2x divided by 2, well, that's going to give me 1x. 10 divided by 2 is 5, so x is equal to 5. And then I can double check. 2 times 5 is equal to 10. Hey, so if x is 5, my equation stands true. Okay, last example quick here. 3x, so x, x, I have 3 x's, and I have, let's say 5 negatives. So I'm actually going to do 5 negative integer chips. And let's say that a circle, an open circle is equal to negative, and a closed circle or a dot is equal to positive. Okay, so remembering back to integers and integer chips. So I have 5 negatives, 3, 4, 5. And on the right side, I have 13 positives. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so on the left side, I want to get just one x there. So the first thing I'm going to do is I'm going to get rid of these counters. Now, if I have 5 negative counters, how can I get rid of them? Well, if you remember, one negative, one positive counter equals 0. It's called a 0 pair. So for each one of these negatives, if I put in a positive, so I added in 5 positives here, they all cancel out. I would also, but to keep it balanced, since I put 5 positives in on the left, I'm also going to have to put 5 positives on the right. 1, 2, 3, 4, 5. Okay, and now my equation remains balanced because I did the same thing on both sides. These all cancel out and they're 0 though. Okay, so far in equation, what we did was we added 5 here and we added 5 here. Now what's left on our teeter-totter is 3x is equal to, since these canceled out, 3x is equal to 18. I want to take 2 of these x's away, which means I'm taking 2/3 of it away, or I'm dividing it by 3. If I divide 3 x's by 3, I'm left with just 1 x. Okay, if I split the 3 x's into 3 groups, how much would be in one group? Just 1 x. So I take away 2/3 of it. Now if I was to try to split, here I'm actually going to draw it. So I had 3 there, I'm going to draw the 3 right here. I could split this into 3 groups. 1 group, 2 group, 3 equal groups of 6. If I take away 2 of those 3 groups, or figure out how much would be in one group if I split it into 3 groups, there's 6 counters there. So I divided the left side by 3, divided the 3 x's by 3, divided 18 by 3. 3x divided by 3 is equal to 1x. 18 divided by 3 is equal to 6. So x is equal to 6. So now I can plug that back into my equation. I imagine putting this 6 back in place of x. Now I follow order of operations. So I'd have 3 times 6 is 18, minus 5 is equal to 13. Hey, so when I put 6 in there, my equation's right. Okay, so that's just a quick review of using that teeter-totter. We're just going to go over these questions not using the teeter-totter method, but just still we're still doing it. We're still doing the exact same thing we do on the left. We have to do on the right to keep this equal sign true, to keep the teeter-totter balanced. Whatever we do on the left, we do on the right. And we're going to do the reverse order of operations and the opposite operations. So I want to get x all by itself. So first, I need to get rid of this 12. So it's positive 12, so I'm going to subtract 12, and I'm going to subtract 12. Okay, this is how I want you to be writing it out as well. The 12s cancel out. So on the left side, all that I'm left with is 5x. And on the right side, 32 minus 12 is equal to 20. Okay, on the left side now, I have 5 times by x. To cancel out that 5, I do the opposite operation, so I divide by 5. Okay, just like doing the opposite of addition was doing subtraction. The opposite of multiplication is division. To keep it balanced, I do the same thing on both sides. Now I've done on both sides, I can simplify. The 5's cancel out. I'm left with just x, which is what I want. On the right side, 20 divided by 5 is 4. Okay, there's my solution. I can double check by putting it back into my equation, put what x is equal to, change that to a 4. Okay, so now I can erase this. I can change this to 5x, whatever, that's times by 4 plus 12. 20 plus 12 is equal to 32. Hey, 32 is equal to 32. Okay, so I just plugged it back in, the solution that I got, that x equals 4, I just checked. Okay, so make sure you always do that. Especially on the test, you should always know if you're right or not, because you should do that check. Okay, I'm not going to do it for the rest of these here, but you should be making sure you're doing that. Okay, so on the left side, I have 8 plus 6x is equal to 50. Okay, I have to get x all by itself. So first I need to get away, since we're doing the opposite order of operations, I need to first do the opposite of what is being added or subtracted to it. So this is 8 plus 6x, which means that I have, this is a positive 8 up here, positive. And I want to get rid of that first, before I worry about the multiplying by 6. So I'm going to have to subtract 8 and subtract 8. Now when these cancel out, all I'm left with, this addition symbols here, that just tells me that this is positive 6x. So I have 6x is equal to 50 minus 8 is 42. Okay. Now x is being multiplied by 6. I want to do the opposite. So divide by 6 on both sides. The 6's cancel out. I'm left with x is equal to 42 divided by 6 is 7. So x is equal to 7. Okay, here's a bit of a tricky one over here, because it involves some negatives. So you have to remember your integers unit. So I have 4x minus 15 is equal to negative 7. I want to get x by itself. First, going to get rid of what is being added or subtracted to it. So it's minus 15. I'm going to do the opposite. I'm going to add 15 to cancel out that minus 15. That's subtract 15. I'm going to add 15 here as well. On this side, 15's cancel out. I'm just left with 4x is equal to now negative 7 plus 15. So I'm adding 15, so my numbers, it's adding a positive 15, so my value is going to get bigger from negative 7 by 15. So to go from negative 7 up to 0 would be 7. What's left to have gone up 15? Well, I'd have to go up 8 more. So negative 7 plus 15 is 8. And then I can divide by 4. Divide by 4 to get rid of that multiplying by 4 on the x. Now I'm left with just x is equal to 2. Okay, so I got that as my solution. I'll actually check this one. Important to check it. So I go 4 times by 2. So I'm replacing this x here with what I got for my solution. Minus 15 is equal to negative 7. I have to do multiplication now. We're following regular order of operations because we're not solving for a variable. 4 times 2 is 8. Minus 15 is equal to negative 7. And so 8 minus 15 is negative 7, which is equal to negative 7. So left side is equal to right side. Therefore, my solution is correct. Okay, this last one here is a little bit tricky. This ax plus b is equal to c. But let's solve for x. I know there's no other numbers here. We're not actually going to be able to find what number x actually is. But I just want to show that even if you just have variables, you can still rearrange things, which later in math is going to be very necessary and useful. So we can still follow the same steps. I want to get x all by itself on the left side. What do I need to do to get rid of these other things? Well, x is being multiplied by a. It's also having b added to what a times x is equal to. So first I'm going to have to take away this b, subtract by b. and C subtract by B. Okay, now these B's cancel out. I'm just left with AX, A multiplied by X, is equal to, I don't know what the answer to C minus B is, but I can still write C minus B. Okay, now X is being multiplied by A. I can divide by A on that side. That will still cancel out A. So whatever A is, if I divide it by itself, it'll cancel out. And on the right side, I can still divide that whole thing, C minus B, whatever that answer is. I'm dividing that by A. So now I've gotten left X is equal to C minus B, the answer of that, divided by A. And there's my answer to what X is equal to. Now I don't know what C, B, and A are equal to. But once we did, I could solve for X that way as well. Okay, so you can still rearrange things even if you actually don't have numbers, because, you know, B and B represent the same value. So positive B, negative B, those cancel each other out still. So just something, this isn't, you know, this question we haven't really got into. There might just be some bonus or challenge questions about rearranging formulas with only variables, but don't stress too much about it. Okay, just one quick word problem here. So Joe and Bob each collect stamps. The number of stamps Joe has is 8 less than twice the number Bob has. A little bit of a confusing sentence. Joe has 36 stamps. How many does Bob have? So let's determine some variables. So Joe will be J, Bob will be B. They each collect stamps. So the number of stamps Joe has. So we can start to make this. Joe's stamps is equal to, the number of stamps Joe has is, or you could say is equal to, 8 less than twice the number Bob has. So sort of confusing. I always like to find that other variable right away. So how much Bob has. So twice the number Bob has. Twice the number Bob has would be 2B. But he has 8 less than that. So 8 less than 2B I could go show by 2B minus 8. Okay, so this is my equation. The number of stamps Joe has. So Joe has, I figured out that's J, and that's equal to twice the number Bob has, 2B, and it's 8 less than that, so minus 8. So just because it shows 8 less than first in my sentence, doesn't mean that it should come first in my equation, because it's 8 less than the number, twice the number Bob has. So you don't show that by going 8 minus 2B. That shows 2B less than 8. This shows 8 less than 2B. So this is our equation. This is the tricky part of these word problems, is sometimes making this equation. So Joe has 36 stamps. So I can substitute this in for J, because we know how many Joe has. So Joe actually has 36 stamps. And that is equal to 2B minus 8. So now I only have one variable. The question's asking how many does Bob have, so that's good that I just am missing his variable. So if there's ever the question, like how many does, you know, Bob have or Cindy have or whatever, that means that should be the variable that you have left in your equation. And now I can solve. So I add 8 on both sides. I'm left with 44 on the left here. The 8's cancel out. And I'm left with 2B, 2 times the number Bob has. So twice the number of stamps that Bob has is 44. I divide by 2. And I divide by 2. I'm left with Bob's. Doesn't matter that the variable's on the right. That's fine. The number of stamps Bob has is equal to 22. Okay. And there you have it. Okay, so just a little bit of review, just going over some of these questions. You can watch the other videos again if you just want to focus on some of the earlier things. And yeah, there's other YouTube videos there too. I'm not offended if you're watching, you know, Math Antics, brilliant math YouTuber. You can watch other ones as well. Do the work in your textbook to help you study. Talk to you later, grade 7s.